Hello children, welcome back to my educational channel, Father's Educational Companion. In the last class, we have discussed the 8th grade physics. The lesson named Force and Pressure. In that, you have learned about force, its characteristics, applications, and different types of force. You can get the notes and textual solutions in the description box of that video. And I have uploaded all the notes, textual solutions on the PPT in my Facebook page, Faris Educational Companion. Visit the page, like and get the resources to enhance your learning. Today we are going to learn the second part, pressure. Do you ever try to cut vegetables or fruits with a blunt knife? Why do we use a sharp knife for that? Let's have a look. Which is easier? Do you know the reason? Do you ever try to hang a picture on the wall using a nail? Take a nail. Try to push the nail on the wall by its head. Did you succeed? Now try to push the nail by the pointed end. Why did this happen? It happens due to its very thin edge. The area over which the force is applied plays a role in making these tasks easier. The force acting on a unit area of surface is called pressure. We can find pressure using the formula P is equal to F by A. Pressure is equal to force divided by area. At this stage, we consider only the force that acts perpendicular surface on which the pressure is to be counted. We'll consider another situation. Do you ever travel by a train? There you have may seen porters. Why do they place a round piece of cloth on their head? Do you know the reason? By doing this, they increase the area of contact of the load with the head. So the pressure on their head is reduced and then they find it easier to carry loads. These all are applications of pressure. Try to find out more applications from the real life situation. Let's solve some numericals. Now you have learned the formula to find pressure. Pressure is equal to force divided by area. Do you know the unit of pressure? Children, we need to ensure that we are writing units while doing numerical. It is very important because the unit describes the scale of measurement. The area is measured in square meters that you have learned already. And force is measured in newtons and it is denoted by the letter capital N. Now can you tell me the unit of pressure? Now we have learned pressure is equal to force divided by area. Unit of force is Newton and unit of area is meter square. So pressure will be F by A, means its unit will be Newton per meter square. and it is also known as pascals. I will teach you a quick way of remembering how to calculate one of either pressure, force or area using this formula. For this, I am showing the formula in a triangle like this. Let's see how to remember it quickly. Here, the horizontal line represents division and the into sign represents multiplication. Now, here the first triangle, I am going to find out pressure that I have represented by a red circle. Now, cover up the one we want to find out and substitute the values into the formula for the two remaining quantities in the triangle. See, P is equal to force, the horizontal line shows division, then area. So, P is equal to F by A. Now, we will find out second quantity. Here, I am going to show you how to find area. So, cover up area and look at the triangle. It's force, horizontal line, then pressure. That means force divided by pressure. So, we will get area is equal to force by pressure. Now, look at the triangle. Here I am going to find out force. So, other quantities are represented with into mark. That means F is equal to P into A. Hope you have understood how to find pressure, force and area using this triangle easily. Let's solve some problems related with force, area and pressure. Look at the first example. A force of 150 Newton is being applied over an area measuring 0.5 meter square. Calculate the pressure on the object. Ensure that you have writing the correct unit. So first, constructing the triangle. Here we are going to find out pressure. So, covering up the P, we must divide the force by the area. So, P is equal to F by A. Here we have force is given as 150 Newton and the area we have 0.5 meter square. So, pressure will be 150 divided by 0.5 which is equal to 300 Newton meter square. Is it easy, right? Now, go for the second example. Here we are going to calculate force. A woman is applying 300 Newton per meter square of pressure onto a door with her hand. Her hand has area 0.02 meter square. Work out the force being applied. Consider the triangle. Here we are going to find out force. So, cover up it and we'll get P multiplied by A, that F is equal to P into A. In this example, the woman is applying 300 Newton meter square pressure. So, P is equal to 300 Newton meter square. And here we have area is equal to 0.02 meter square. And the force will be 300 multiplied by 0.02 and it will be 6 Newton. Now, it's your turn. Try it yourself. here is your chance to calculate area. Later I will be uploading notes for the topic pressure. There you can find the correct answer. Shall we move? Do liquids and gases also exert pressure? Does it also depend on the area which the force acts? Let's learn in detail. First, we'll check with liquid pressure. How do liquid exerts pressure? When we pour liquid into a vessel, then the weight of the liquid pushes down on the base of the vessel, producing a pressure. All liquids have weight. All the liquids exerts pressure on the bottom and walls of their container. Let's learn in detail. All the liquids exert pressure on the base or bottom of their container. Take a balloon and tie it at the lower end of a glass tube and hold vertically as shown in the figure. Pour some water in the tube. What happens? Balloon bulges out because the water column exerts pressure at its bottom. So we can see that all the liquids exert pressure on the base or bottom of their container. Take a transparent pipe and a rubber balloon. Stretch the balloon tightly over one end of the pipe. Hold the pipe in a vertical position and pour some water into it. Does the balloon bulge out? Note down the height of the water column in the pipe. Pour some more water. Observe the balloon and the height of the water column. What you have understood from this activity? Repeat the activity. You can conclude that all the liquids exert pressure on the bottom of its container, which depends on the height of its column. All liquid exerts pressure on the walls of its container. Let's consider another activity. Take a plastic bottle, fix a cylindrical glass tube a few centimeters long near to its bottom. Make sure that the water doesn't leak from the joint. Cover the mouth of the glass tube with a balloon. Now fill the bottle up to half with water. What do you observe? The balloon gets stretched and bulges out. Now we'll do another activity. Take a used can or a plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. Observe it. Do the different streams of water coming out of the holes fall at same distance from the bottle? What does this indicate? Liquid exerts equal pressure at same depth. Take another plastic bottle, drill 3 holes on the same side of the bottle from the mouth. Now fill the bottle with water. What do you observe? You can see that water from the uppermost hole is found to travel the shortest distance, and water from the lowermost hole shoots out farthest of all. What do you understand? As the depth of water increases, the pressure of water increases gradually. The pressure of liquid increases with depth. Suppose you are riding a bicycle. Suddenly, the bicycle tube got a puncture. What happens to the air in the bicycle tube when it has a puncture? Do you ever try to inflate a balloon that has a hole? These observations suggest that air exerts pressure on the inner walls of an inflated balloon or a cycle tube. So we can say that gases too exert pressure on the walls of their container. Take a good quality rubber sucker as shown in the figure. Press it hard on a smooth plain surface. Does it stick to the surface? Now try to pull it off the surface. Do you feel any difficulty? When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of the atmosphere acts on it. You need to apply a large force to overcome the atmospheric pressure. Atmospheric pressure is due to the weight of air present in the atmosphere above us. Atmospheric pressure also acts in all the directions. On the surface of the earth, the atmospheric pressure is maximum at sea level. That's all for this class. We have completed the lesson force and pressure. In this class, what you have learned? We have discussed about pressure and applications of pressure. Liquid and gases exert pressure on the walls of their containers, and the pressure exerted by air around us is known as atmospheric pressure. I will be uploading the notes as soon as Don't forget to visit my Facebook page to get the stuffs. Subscribe, like and follow my YouTube channel. And don't forget to ring the bell to get the notification. Thank you, students. Thanks for watching. See you soon with another lesson. Till then, bye.